Hey guys, welcome back to another problem in our LeetCode 75 study plan series. So we are going to continue into our linked list category. And our problem today is a reverse linked list problem. It's ranked as easy. I would agree with this ranking. I do think it's pretty easy. It's actually a pretty fundamental thing that you need to know for computer science in general and data structures and algorithms. So definitely make sure to watch this closely and to make sure that you master how to do this because you're going to need to know how to be able to do this. So it's pretty simple, right? Given the head of a singly linked list, reverse the list and return the reverse list. So pretty self-explanatory, straightforward. We have 1, 2, 3, 4, 5, and then we need to turn that into 5, 4, 3, 2, 1. And there's two ways that we can do this. There's the iterative approach, which is using a for loop, and then there's also recursion. We're going to be doing the iterative approach today because the iterative approach uses less space. So it's more efficient, right? So a recursive approach is going to have a time complexity of big O of n and a space complexity of big O of n, which is relatively fast, but with an iterative approach, we're not declaring any variables that require extra space. So we're going to be able to just loop through the linked list once, which is going to be big O of n time complexity, and then we're going to not use any extra space, so we're going to have constant big O of 1 space. So let's go ahead and get right into the code implementation. So it's pretty in terms of like what we're going to do here to help you kind of understand better, actually right before we dive into this implementation, is that understand what a linked list is first, right? For the linked list, we want to a linked list has pointers, right, to the next node. So 1 has a pointer to 2, 2 has a pointer to 3, so on and so forth. So if we're going to reverse this list, what we need to do is get that pointer to point to the previous node in the list. However, we have to be careful because there's only one, it's not a doubly linked list, it's just a singly linked list. So there's only one pointer in each node. So we can't lose our place when we're switching that. So that's why we're going to have to create a temporary node, which I'm going to show you in this implementation. So yeah, let's go ahead and dive right into it. So like I said, we're going to need to point to the previous one. So let's go ahead and make a list node, and we can call this previous. And we're going to set this to null for right now because starting off, there's not going to be a negative node, right? That a negative index node that's not going to exist because we're starting from the beginning, right? And then what we're going to do now is we're going to have our current node, and we're going to set that to the head since we are starting from the beginning. All right, so now what we want to do is break into our loop. So we're going to use a while loop to iterate through each node in our linked list. So what we'll do is while current is not null, okay? So like I said earlier, we have to create a temporary variable or a temporary node so we don't lose our place. And this temporary node is going to point to the next node. So that allows us to iterate through this entire linked list. So let's go ahead and create our list node temp, and then we'll set this to current.next. Okay, and then now what we want to do is we need to adjust the pointer. So instead of pointing to the next node in the list, it's actually going to point to the previous node in the list. So current.next is equal to previous, right? So that's basically setting the first. So think about it in our first iteration. We're setting the first node, the next, we're setting it to null, right? Because basically, since we're reversing this list, the first node, it doesn't have a previous node, right? Okay, so now what we want to do is we want to set the previous node to the current node. Okay? And then what we want to do is set the current node to the temp node. And that allows us to link through our list, right? And then all we have to do is, you got to imagine, once we iterate through all the nodes in the list, we're going to want to return the previous node, right? Okay. Oh, sorry, forgot my return. Okay, so we return previous, and then let's go ahead and run this. Cool, so we passed the first 3 test cases, so let's go ahead and submit. All right, there we have it. We have our fully accepted solution. I don't know why this has a red squiggly. It's just a mistake, probably. So yeah, like I said, the time complexity, I explained it earlier. It's just going to be big O of n time complexity and big O of 1 space complexity. So definitely know how to do this. I'm going to drop a couple resources in the description, one for learning more about the iterative approach, and then one for the recursive approach if you want to try the recursive solution in your own time, which I would definitely recommend if you aren't familiar with recursion as a concept, or you're just rusty and you want to brush up a little bit. So yeah, there you have it. If you enjoyed the video, please go ahead and leave a like, and we will see you next time.